Alright, this is a continuation of the confidence intervals. This is just doing tests for slopes. So we still have a four-step process here. We're just testing the slope now. So your null hypothesis will be beta is equal to 0. This is the easiest scenario. There are other times where you might not say that, but for most part it's going to be equal to 0. You can test that beta, remember beta is the population slope, is greater than 0, or beta is less than 0, or beta is not equal to 0. If beta is greater than 0, that's like testing that there's a positive relationship, the slope is positive. If beta is less than 0, it's testing if there's a negative relationship, the slope is negative. And if beta is not equal to 0, it's like testing that there's no relationship. You're doing a t-test for slope. The conditions, remember it's that linear, same thing as it was yesterday. Alright, here's the test statistic. So it's the sample slope minus the population slope, or whatever you're thinking the population is. In this case it'll be 0, divided by that standard error of the slope. The degrees of freedom are still n minus 2. To find the p-value, you would use that TCDF command, lower bound, upper bound, comma the degrees of freedom. Do your last step the same way you've been doing it. Alright, here's an example about tips and time. So when you just look at the scatter plot, you see that there is a weak positive linear relationship. Here's computer output. There's the release score regression line, so I just got it from the output here. There's my interpretation of slope and y-intercept. Alright, to carry out the test, so her question is that, is there evidence that customers who stay longer give larger tips? So that means as the time is increasing, the tips are increasing. So I'm looking for a positive relationship. So I'm testing, is the slope greater than 0? Is beta greater than 0? You're going to write out in words what it is, just like we did before. We're doing a t-test for linear regression. Alright, there's that liner check. So I'm just going back up here. There's my residual plot. There's my normal probability plot of the residuals. There's the scatter plot. And so I'm just answering those questions based on those graphs. Alright, when I get the test statistic, if you notice I don't have any calculations there, there's a couple things. First of all, here's this next column right here. So now I'm paying attention to these other columns. This is your t, this is your test statistic. Again, the slope data is only in this row. So this is the t for the slope, so it's 1.23. And this is the p-value. In this computer output, remember they always give you the two-sided p-value. So what I wrote here is I took the t straight from there, and I took the p-value and divided it by 2. Well, another way you can do this, if you go back up here, this formula, remember it's b minus beta over SEB. So I could do, I could take the b, which in this case, let's do this way. So my b is my 0.03013, and I'm going to divide it by the standard error of the slope, which is that number right there, so the 0.02448, and there's that 1.233, or 1.23. I can then go to that TCDF command. That would be my lower bound, comma my upper bound, comma the degrees of freedom. The degrees of freedom for this problem, she has how many values here? 2, 4, 6, 8, 12. So then my degrees of freedom are 10. And there's that p-value, okay? So again, it's just half of that. So that's another way I could get it. There's a third way that I could get those numbers, is I can type those into this list into my calculator. So there's those values in my calculator. When I go to Stat, over to Tests, I'm going to use F, the linreg t-test, list 1, list 2, and then I'm going to select this last option here, because it's the greater than 0. Frequency you leave as 1, reg equation you leave blank. I'm going to hit calculate. So there's that test statistic again, and there's the p-value. So that's just another way. So that's 3 ways that you can get those values. Like I said, I just went straight to the computer output because it was given to me. And the p-value is greater than alpha, so they must have given me a significance level right there. So I'd fail to reject. There's not enough evidence to support that as time increases, the tip increases. Here's another example going back to before. Here's the confidence intervals. Remember, you were doing confidence intervals. We could do a hypothesis test, a two-sided test. So this was about those Honda CRVs, which we looked at a long time ago. This is a 95% confidence interval for the advertised price. So what conclusion can you say here? So since 0 is not in that interval, I can reject and say that there is a relationship between the number of miles driven and price. So that was just about the slope, and that is that for that one.